Somewhere beneath the South China Sea, a Virginia-class submarine is already running a fire control track on a warship that does not know it exists. The surface ship is the Type 055 destroyer, 180 meters of steel, 12,000 tons displacement, the most capable surface combatant the People's Liberation Army Navy has ever put to sea. Its active radar is sweeping a 360-degree arc every few seconds. Its sonar operators are scanning. Its electronic warfare suite is monitoring every frequency the enemy might use. By every measure visible from the bridge, this ship owns the water around it, and yet the geometry is already locked in against it, because the threat it cannot see has been watching it for over an hour. Here is the question that frames this entire breakdown. In a confrontation between the most advanced surface combatant in the Chinese fleet and a US Navy submarine running silent below the thermal layer, who actually holds the clock? Who gets to decide when, or whether this engagement happens at all? The answer is not determined by missile counts or radar range. It is determined by acoustics, patience, and the cold mathematics of who radiates and who does not. Stay with this, because the answer reshapes how you think about every surface group operating in the Western Pacific. Let us set the scene precisely, because precision is what makes this asymmetry visible. The South China Sea. Somewhere east of the Paracel Islands, in water between 200 and 800 meters deep, deep enough to hide beneath the thermocline, shallow enough that the acoustic environment is complex and cluttered with biologics, merchant traffic, and the ambient noise of one of the busiest shipping corridors on Earth. This is not the clear, cold, deep water of the North Atlantic where Cold War submarine doctrine was written. This is layered, complicated, contested water. And that complexity, counterintuitively, favors the patient, the silent, and the passive. The Virginia-class submarine has been at this position since before dawn. The crew came to periscope depth once, briefly, 4 hours ago. A 30-second exposure to upload a burst transmission and copy the operational message traffic from fleet. Then it went back down. Since then, nothing. No transmissions. No mast exposures. No active systems of any kind. The ocean above does not know it is here. The ship below the thermal layer is a ghost made of steel and discipline, and it intends to stay that way. The Type 055 entered sensor range 97 minutes ago, emerging from the northwest at a base course of 140 degrees and a speed of 18 knots. The passive sonar operators in the Virginia-class control room heard it long before any other system could have detected it. A faint but consistent set of tonals in the low frequency band, rising gradually from the noise floor as the range closed. The contact was designated Master 1. The tracking party went to work. The Type 055 is a formidable machine. Let that be clear from the start. This breakdown does not work if we underestimate the adversary. The 055 carries 112 vertical launch cells capable of firing the YJ-18 anti-ship cruise missile, the HHQ-9B surface-to-air interceptor, and the U-8 rocket-propelled torpedo. It runs an active phased array radar, the Type 346B, broadly analogous in concept to the SPY-1D on an Arleigh Burke. Its hull-mounted sonar, the SJD-9, can detect submarines in certain conditions. It carries 2 Z-9C anti-submarine helicopters. On paper, this is a ship designed to kill submarines, and the Virginia-class Block V submarine watching it from below is not impressed by any of that. Here's why. The Type 055's most capable sensors, its radar, its hull sonar, its helicopter dippers, are optimized for the surface and near-surface environment. The radar is extraordinarily good at finding things above the waterline. The hull sonar can detect certain acoustic signatures at certain ranges under certain conditions. But none of those systems can see through the thermocline with the precision required to localize a submarine that is actively choosing not to be heard. What the Virginia-class is doing right now is nothing. That is the point. It is making no transmissions. It is emitting no active sonar pulses. Its machinery is mounted on acoustic isolation systems so effective that at combat depth, running at 4 knots, it is quieter than the ambient ocean around it. The Type 055 cannot find what does not announce itself, and the Virginia-class has no intention of announcing itself. What the Virginia-class is doing instead is listening. This is passive sonar, and understanding it is the entire key to understanding this engagement. Active sonar sends out a pulse and listens for the return. It tells you what is out there. It also tells every passive sonar within 50 kilometers exactly where you are. Active sonar is loud. Active sonar is a megaphone. In a contested undersea environment, active sonar is a liability disguised as a capability. Passive sonar does the opposite. It listens. It collects. It processes. The BQQ, 1-0 bow array on the Virginia-class is one of the most sensitive passive sonar systems ever fielded. Alongside it, the TB-29A thin-line towed array streams hundreds of meters astern. A second set of ears tuned for low-frequency tonals in the range where surface ship machinery radiates whether it wants to or not. The two systems work together in a way that multiplies their individual effectiveness. The bow array gives bearing resolution. It can tell you the direction a sound is coming from with considerable precision. The towed array gives frequency resolution. It can pull low-frequency tonals out of the noise floor at ranges where the bow array alone would miss them entirely. The combat system fuses both inputs continuously, running a frequency time analysis that builds a picture of every sound source in the water column around the submarine. Most of those sources are irrelevant. Biologics, distant merchants, rain noise from a squall 40 miles to the northeast. The combat system filters and classifies. What remains, persistent on a consistent bearing and slowly shifting in bearing rate as the geometry changes, is Master 1. And the Type 055 is radiating constantly. Here is where the obstacle appears. And it is a real one. The South China Sea acoustic environment is not cooperative. Biologics, merchant shipping, rain, and thermal gradients create a noise floor that can mask a target's signature at long range. 3 weeks before the scenario we are walking through, this same Virginia-class crew spent 72 hours attempting to classify a contact that turned out to be a Chinese fishing trawler with a particularly noisy diesel. The towed array gave them a bearing. The combat system built a track. The track was wrong. That kind of uncertainty is the hardest part of the undersea fight. Not the technology, but the patience required to trust the data when the data is ambiguous. What the crew does in those moments is not guess. It maneuvers. A deliberate change, of course, at low speed. A few degrees, sustained for long enough to generate a new bearing line, gives the fire control team 2 lines of bearing from 2 different positions. Where those lines intersect is where the target is. This is called target motion analysis, and it is part geometry, part intuition, part experience that cannot be downloaded from a manual. The Virginia-class has been working this track on the Type 055 for 63 minutes. They have 3 intersection points. The solution is tight. I've gone through the open source acoustic analysis on platforms like this, and one detail keeps surfacing in every serious treatment of the problem. The Type 055's gas turbines, at sprint speed, produce a tonal signature in the low hundreds of hertz range that is detectable at ranges well beyond what its own sonar can compensate for. The ship is, acoustically speaking, announcing itself across a significant portion of the water column below it. The Virginia-class combat system has that tonal on file. The track has been confirmed. Now let us talk about what the Type 055 is actually doing during this 63 minutes, because this is where the asymmetry becomes almost brutal in its clarity. The Type 055 is operating as designed. Its Type 346B radar is sweeping continuously. Its electronic warfare suite, the ZKJ-4B integrated combat system, is monitoring for radar emissions, for data link activity, for any sign of an adversary surface force or airborne threat. Its bridge watch team is conducting visual and optical surveillance. Its SJD-9 hull sonar is pinging, actively, on a search pattern designed to find submarines in the layer above the thermocline. And every single one of those active transmissions is a data point feeding into the Virginia-class fire control solution. Every radar sweep is a timing reference. Every active sonar ping tells the passive sonar operators below exactly what frequency the search is centered on, and therefore what frequency range the Virginia-class does not need to worry about masking. The Type 055 is, in effect, cooperating with the intelligence collection being conducted against it. On the bridge of the Type 055, the watch officer is running a routine surface picture compilation. The radar returns are clean. The electronic warfare intercepts show nothing unusual. No fire control radar illumination, no data link emissions that would suggest an adversary surface force is within range. The ASW picture, as far as the Type 055 is concerned, is clear. The hull sonar has detected nothing below the layer. The 2 Z-9C helicopters are being held at readiness on deck rather than deployed. Their crews on a 4-hour rotation, because the threat assessment does not currently justify the fuel expenditure and crew fatigue of sustained active dipping operations. This is a reasonable operational decision based on the information available to the surface commander. It is also precisely the decision that works in the Virginia-class's favor. What's most surprising about this dynamic isn't that it exists in theory. It's how complete the information asymmetry becomes in practice. The Virginia-class, within 40 minutes of establishing contact, knows the Type 055's course, speed, heading, and the approximate operating frequency of its active sonar. The Type 055 knows none of those things about the Virginia class. It does not know a submarine is present. It does not know it is being tracked. It does not know that a fire control solution is being refined against it with every passing minute. The surface ship is hunting the surface and the sky. The threat is below. And the thermocline is keeping it invisible. Let us walk through the fire control geometry, because this is where the Virginia class earns its position at the top of the undersea warfare hierarchy. The AN/BYG-1 combat management system aboard the Virginia class is processing continuous input from the bow array, the towed array, and the track data from the 3 TMA legs completed in the past hour. The system has generated a fire control track, not a detection, not a contact of interest, a fire control track. That means the solution is good enough to prosecute. In the submarine's control room, the atmosphere is deliberately quiet. The commanding officer stands at the fire control console reviewing the solution parameters. Range estimate, inside 20 kilometers. Bearing, 078 degrees. Course and speed, confirmed within acceptable error margins for weapons employment. The executive officer has reviewed the solution independently, as procedure requires. They agree. The weapons officer has prepped the tube status report. 2 MiG-48 AD cap torpedoes are ready in tubes 1 and 2. The 3rd and 4th tubes hold reloads. This is not a patrol checking a contact. This is a warship at the peak of readiness, holding a weapons quality solution on a target that has no idea the conversation has already gone this far. At this point in the scenario, the commanding officer of the Virginia class has a choice that the Type 055 does not know it is participating in. He can hold. He can continue tracking, refining the solution, waiting for orders, watching the surface ship operate in complete ignorance of what is below it. Or, if the order came, he can prosecute. Put yourself in that captain's position for a second. 63 minutes of silent work, a tight solution, a target that does not know you exist, and a weapon that closes the gap faster than any warning system can respond. That position is not primarily about firepower. It is about time, about who owns the clock, if the order came. Because here is the second layer of this asymmetry, and it is the one that reshapes the entire strategic picture. The order does not have to come for the advantage to be real. The Virginia class does not have to fire a single weapon to change how the Type 055 operates. The mere possibility, the operational uncertainty that a U.S. submarine might already have a solution, is enough to constrain the surface group's freedom of action. We will come back to that. First, let us finish the prosecution scenario, because it illustrates exactly why the uncertainty is so constraining. The MiG-48 AD cap heavyweight torpedo. This is the weapon at the end of the fire control solution, and it is worth understanding what it brings to the problem. The MiG-48 Block 7 AD cap, advanced capability, is a wire-guided, active/passive homing torpedo. It is not a simple straight-running weapon. It is, in effect, a small autonomous undersea vehicle that can be steered by the launching submarine during its run, updated with course corrections via a guidance wire, and then handed over to its own seeker head for terminal homing. Its range exceeds 50 kilometers. Its speed exceeds 55 knots. Its warhead is sufficient to mission kill any surface ship currently in commission. The engagement geometry works like this. The Virginia class has a fire control solution placing the Type 055 at a known bearing and estimated range. The torpedo is fired from a depth where the tube-launched weapon can clear the boat safely. Then it dives to its transit depth, below the thermocline, in the same acoustic shadow that has been protecting the Virginia class throughout this engagement. It runs toward the target at high speed. At the appropriate point, it climbs back through the thermal layer and goes active. At the moment the Type 055 sonar detects an inbound torpedo in terminal homing mode, the MiG-48 is already inside the reaction time for any countermeasure. The Type 055 can launch decoys. It can cavitate its propellers, accelerating to flank speed. It can attempt an emergency turn to comb the torpedo's track. All of these are valid countermeasures against a torpedo detected at range. Against a torpedo detected at close range from a solution that was developed in silence over more than an hour, the geometry is not favorable. The wire guidance element deserves particular attention because it closes a vulnerability that older unguided torpedoes left open. If the Type 055 detects the incoming weapon and takes immediate evasive action, a hard turn, a speed sprint, a countermeasure deployment, the Virginia-class fire control party can update the MiG-48's targeting solution in real time via the guidance wire, steering the weapon to compensate for the maneuver. The torpedo is not chasing a fixed point in space. It is chasing a continuously updated estimate of where the target will be. The Type 055 can run. The guidance solution runs with it until the wire is cut and the seeker head takes over at terminal range. There is also the Tomahawk. The Virginia-class Block V carries the Virginia payload module, an additional section housing 28 Tomahawk cruise missiles in addition to the standard torpedo room. Against a surface target, a sub-launched Tomahawk Block V with maritime strike capability represents a second engagement option that extends the effective reach of the Virginia-class to ranges where the Type 055 cannot begin to locate the launching platform. A Tomahawk fired from 60 nautical miles is inbound for well under an hour. The Type 055's radar will detect it, eventually. But the submarine that fired it is already repositioning, still silent, still undetected. The combination of the two weapon systems. A heavyweight torpedo for close engagement and a long-range cruise missile for standoff prosecution means the Virginia-class has no single engagement envelope. It can strike from inside 20 kilometers or from beyond 60 nautical miles. The Type 055 cannot optimize its defenses against both simultaneously. Choosing to sprint away from a close torpedo threat increases its acoustic signature and makes it easier to track for a follow-on Tomahawk shot. Choosing to slow and go quiet to reduce its acoustic signature reduces its ability to maneuver out of the torpedo's terminal acquisition basket. Every defensive choice in one dimension creates a vulnerability in another. Here is where we owe the honest accounting. The Virginia-class is not invulnerable. The Type 055 group is not operating alone in any realistic scenario. It would be part of a carrier battle group built around the Fujian carrier or a Shandong-class vessel, with accompanying Type 054A frigates carrying their own sonar and Z-9C helicopters conducting coordinated active dipping sonar searches across a wide area. A coordinated multi-static sonar barrier, multiple active sources, multiple passive receivers, organized to cover different depth layers and different frequency bands, can complicate the geometry for even a quiet submarine. The South China Sea's shallow water in certain areas reduces the Virginia-class's ability to use depth as a shield. In water under 150 meters, the thermocline may not be present, or may be too thin to provide reliable acoustic shielding. The submarine must work harder, maneuver more carefully, and accept that some of its acoustic advantage is environment-dependent rather than absolute. And there is the human factor, the hardest variable to quantify. 63 minutes of silent tracking at 4 knots in a complex acoustic environment places extraordinary demands on the crew. The fire control party must maintain concentration under conditions of near-total sensory deprivation. The commanding officer must make judgments about solution quality and engagement timing under conditions of genuine uncertainty. One of this crew's early tracking runs in this deployment produced a false solution, not from equipment failure, but from misinterpreting a biologic tonal as a mechanical signature. They caught it before it mattered. In a real prosecution, a false solution does not just waste a weapon. It reveals the submarine's position. The undersea environment also imposes its own fatigue on the crew in ways that surface warfare does not. There are no windows. There is no horizon to orient to. The only clock that matters is the one measuring how long the battery endurance holds, how long the crew can sustain the cognitive load of the track, and how many hours remain on the oxygen budget before the next opportunity to come shallow and ventilate. The Virginia-class is a nuclear boat, so the oxygen and endurance picture is far more favorable than a conventional submarine. But the human beings inside it are still finite. A crew that has been running a demanding track for 63 minutes is sharper than one that has been at general quarters for 14 hours. That window is real, and a smart surface commander, one who knows a submarine might be present, would try to exploit it by forcing the submarine to continue tracking through a fatigue window rather than fighting it at a moment of its own choosing. Looking back at the evolution of undersea warfare, what strikes us about this particular asymmetry is how much it is built on discipline rather than technology. The Virginia-class is technically superb, but the edge it holds over a Type 055 group is fundamentally a function of institutional culture. The Silent Service's century-long commitment to the idea that the submarine that speaks first dies first. That culture is not something you can manufacture in a procurement cycle. Which brings us to the strategic weight of this capability. And this is where the scenario stops being about a single engagement and starts being about the entire operating environment in the Western Pacific. The Type 055 group commander, in a realistic scenario, does not know whether a Virginia-class is tracking him right now. He cannot know. His sensors cannot resolve the question. The Virginia-class, running passive below the thermocline, is acoustically invisible to the search assets he has available. He might have a US submarine on his track. He might not. He has no way to find out without triggering the exact revelation he is trying to avoid, blanketing the area with active sonar at high power, which tells the Virginia-class exactly what the search pattern looks like and allows the submarine to maneuver around it. This is the strategic trap, and it is not theoretical. Every surface group commander operating in waters where US submarines might be present has to operate as though a fire control solution already exists against him. That uncertainty constrains speed of advance. It constrains the use of active sensors that would otherwise help localize the submarine. It forces the group to spend helicopter hours on ASW prosecution instead of other missions. It makes every operational decision slightly more conservative, slightly more cautious, slightly more expensive in time and fuel. Consider what that means at the operational planning level. A carrier battle group ordered to transit from the Luzon Strait to a position east of Taiwan has a planning problem that has nothing to do with the adversary's surface forces or air defenses. It has to account for the possibility, the operational certainty, from a prudent planning perspective, that one or more U.S. submarines already has the group tracked before it clears the strait. The group cannot accelerate to reduce transit time without increasing its acoustic signature. It cannot reduce helicopter operations without degrading its ASW coverage. It cannot change course unpredictably to complicate the tracking geometry without burning fuel and delaying its arrival at the operating area. Every choice involves a trade-off against an adversary it cannot see, cannot localize, and cannot engage on its own terms. Here's the take that will probably draw some pushback. The Type 055 is one of the most capable surface combatants ever built. And in a surface-to-surface or surface-to-air engagement, it would be a genuinely dangerous adversary. But the design philosophy that produced it, heavy investment in radar, long-range missiles, electronic warfare, and above-water situational awareness, does not solve the undersea problem. It cannot. The undersea threat is asymmetric precisely because the solutions that work above water do not transfer below it. $1 billion of above-water capability does not buy immunity from a 50-knot MiG-48 fired from a solution developed in silence over an hour. The PLA Navy knows this. The investment in anti-submarine warfare capability, the Type 054A frigates, the hull-mounted sonars, the Z-20F helicopters with active dipping sonar, the maritime patrol aircraft, reflects a clear-eyed understanding that the undersea domain is the vulnerability. But closing that gap takes decades of acoustic data, institutional experience, and a submarine force capable of challenging the U.S. at depth. That is a long program. The asymmetry we are describing today does not dissolve on a procurement schedule. There's a third dimension to this that rarely gets discussed in open source treatments, and it concerns what the Virginia-class learns simply by maintaining this track over time. Every minute of passive collection against the Type 055 adds to a library of acoustic signatures. The specific tonal pattern of this ship's machinery at this speed, under these thermal conditions, in this acoustic environment. That data goes back into the fleet's acoustic intelligence database. The next Virginia-class crew that encounters a Type 055 starts from a better baseline. The signature library gets richer. The classification process gets faster. The asymmetry compounds itself over successive deployments in a way that a surface force operating above the layer cannot easily replicate, because the surface force cannot build the same kind of covert intelligence against an adversary that refuses to radiate. Will that change? Will a Type 055 group operating in the Western Pacific in 2031 or 2036 face a meaningfully different undersea threat environment? Comment why yes or no, because the trajectory here genuinely splits between analysts, and we want to know where you land. What this scenario teaches is not that the Type 055 is a failed design. It is that surface power and undersea dominance are different problems with different solutions, and the United States Navy has spent 70 years building an institutional edge in the second one that is extraordinarily difficult to replicate quickly. The Virginia-class submarine sitting below the thermocline with a fire control solution on a Type 055 is not primarily a weapon. It is a constraint. It is the reason a surface group cannot simply push into contested water at full confidence. It is the silent variable that every operational plan in the Western Pacific has to account for without being able to quantify it. The threat that cannot be seen is the one that shapes the whole board. There is a question worth sitting with after this breakdown. Does a Type 055 group push deeper into contested water knowing that a Virginia-class might already own the firing solution? Or does that uncertainty alone, that irreducible not knowing, keep it cautious? Because if it keeps it cautious, then the Virginia-class has already accomplished its mission without firing a single weapon. That is what deterrence looks like from below the waterline. And if you want to understand how the surface picture changes when a carrier strike group enters that same equation, the countermeasures, the layered defenses, the question of whether Aegis can shift the balance, that breakdown is next.